Hey there guys, and welcome back. So it is time to get this guy polished off. I have one major change that we'll be making, but otherwise everything should go according to plan, as we discussed at the end of last episode. So, last stream, whatever. The one major change is the original intention was to use 2GT belts because I just happen to have those around. I have decided to switch over to just V-groove belt. I don't actually have any V-groove belts. I bought an adjustable V-groove belt because, again, I don't know the size at this point that I'm going to need. And that will be showing up today. I had put off this stream. Instead of doing it this morning, I decided to do it in the afternoon on the off chance that that belt showed up, because I prefer to have it right now for designing, but it is not showing up just yet. So we will continue and just go on our assumptions on how exactly it's going to work. So all that rambling out of the way, let's go ahead and get this guy polished off. So the reason why, actually I should address why I'm switching to a V-groove, even though I have to spend money to get one of those. There's two reasons really. One, the 2GT pulley, it would work, but it's a little small, I think. I could be wrong about that. I just feel like it's probably a little small for something that's going to go 500 RPMs, 5 to 5,000 RPMs. So that's one consideration. The actually more important consideration is that even with the 2GT pulley, I have 8 and 5 millimeter pulleys. That's the ID rather on the pulleys. So I have pulleys with 5 millimeter and 8 millimeter ID, which is fine for the center shaft, which is 8 millimeters. But the problem is the Dremel. The Dremel chuck only holds up to about 3 millimeters. And therefore, we were going to run into a bit of a problem there, figuring out what exactly to do with that. Furthermore, actually, along those lines, at this point, now we're talking about printing custom pulleys, right? So I would have needed a custom pulley for the 10-to-1 reduction ratio to get us from 5,000 RPM down to 500 RPM. So we already had that in the cards, but as soon as we're doing two different pulleys to begin with, like now we have the small pulley, which should have been the 1 in the 10-to-1, would have been on the Dremel. That's where that one would have been, and now that's also going to be custom printed. So since both of them are going to be custom printed, that's one reason why it may just be easier to go to a normal old pulley, V-groove pulley instead, because modeling it up and hoping the printer prints it well enough is still a little bit of an ask. I have done it before, obviously, on the coiler decoiler. I printed my own custom pulleys. So it has been done before, but it's just plain easier to print the other ones. The other thing is, at this point, we're going to, well, I guess, actually, let me throw this one in there. It doesn't have to be a toothed pulley to begin with. We don't need everything to be in sync. It can slip. It's not really that big of a deal if it starts slipping a little bit. So that's one consideration as to why it doesn't necessarily matter whether or not it's the 2GT or just a regular old pulley. The third thing, though, that I keep on stopping myself and interjecting and tangenting on, rather, is that what we're going to do actually is we're going to use the hex drive from the flex shaft. So the flex shaft, in order to use the flex shaft, actually, you know what? I wasn't planning on doing this, but it occurs to me at this point, so let me just clean up a little bit of my desk, that I'm doing a lot of talking, and maybe some of this I should show you. So I've got a project on my desk that I gotta move. Just a second, and then we will be turning on the camera. Go out of the way. And let's see. Now I need the Dremel. Alright. So. Lights, cameras, and actions coming up. There's the lights. And now I gotta plug the camera back in. And hopefully it doesn't hijack my audio again, like it did last week. Let's check the audio mixer to make sure that's not hijacking it. It is not. Cool. Alright. And chances are, when I swap over to camera right now... Actually, that's right. I'll just do a preview really quick to fix the white balance, because the white balance is always off whenever I plug it back in, so... half a second to fix the white balance. Ideally, half a second. My streaming software is going slow as molasses. Alright, screw it. We're hopping over here. It did not want to move, so we are just over here, and I will fix the white balance right now. Yeah, now it catches up. Good bunch of men. Alright, configure, input, white balance, and... you're supposed to be round about there, if I recall correctly. Let's see how my hand looks. Alright, cool. My hand looks fine. And exposure might be a little off, but whatever. Not the point of the stream. So, when you use the Dremel with the flex drive, you got to use this drive nut right here. You can see it has a slot in there for the drive pin right there. And this is what we'll be using. So again, for any old collar or collet or whatever else you might want to put on the Dremel, the quick change, whatever, keyless chuck, for any of that stuff, the maximum, like I said, is 3mm on the ID. Well, if we use the OD, the outside dimensions of this hex drive, then we can just drive it like this. And I threw one on this extra flex drive that I have, and I figure I'll just leave this on the build, on the grinder for... I keep on calling it a grinder. It's a disc sander is really what it is. I keep on calling it a grinder, but since I have an extra one of these, I figure I'll just leave it on the flex drive and just leave the flex drive attached to the sander, and then just plug in over here whenever I want to use it. So that is the plan. So we'll be taking the dimensions off this guy, modeling it up right quick so that we can make a pulley to attach to it. Just, you know, slide the pulley onto it, press it on, and hopefully it does not tear out. So at any rate, it's a lot better than, I think, actually this is a 3.5, but you know, roughly 3mm shaft that we would be connecting to previously. One of those things, when I started this project, I said to you guys, I'm not exactly sure how exactly we're going to get this all done, but we'll figure it out, and well, we're figuring it out. So back over to Fusione and let's get modeling. So let me grab this. I guess I'm gonna have to make a new component. Actually, you know what? We should be able to just break this, honestly, because this is never getting updated. I know for a fact that this guy is a size that works from other projects, so we'll do that, and then I'm gonna toss in new component, and this is the hex drive. Flex shaft hex drive. Get this stuff out of our way. Toss. Do I already have a construction plane here? Bottom? Yep, we do. Cool. So let's just get this hex drive modeled up right quick. There's the bottom. There we go. Bodies. Yeah, yes, bodies. Turn this joint off. Toss a hex in here. The hex is, let's see. And these stupid magnets get in my way again. Hex measures 9.5. 9.5. We are, looks about 10mm tall. Might be 11. Yeah, I think that's 11. I just said 9.5, right? Wow. Yes, 9.5. Alright, 9.5. Whoops. Control Z. 9.5. Just, let's see. I want to try to avoid, as always, putting it on the center spot. Hopefully that is the center point of the circle as opposed to the center point of the sketch, because frankly there should not be a center point on the sketch in my opinion, but I'll complain about that another day. So this goes, technically speaking, actually, let me just do this right quick. Sticks out about 4.2, 420. Blaze it. And honestly about 9.5 as well. So concentric 9.5, and you don't stick out, right? No, you shouldn't stick out, so that's fine. All right, so this, turn that body back on so I can make sure I'm going the correct direction. I am. And I just said about 11. No, 11 is the top one. $420, that's right. 420. All right. Oh, not actually 420, 4.2. And then the hex itself. That one is 11. Whoops, not there. There. 11. Minus. Okay. Huh. What happened there? Okay. Okay. Fusion just being a little weird there. Okay. Flex. Shaft. X drive design. X drive. Base. Hex. There we go. And we should be good. We'll just toss really quick. A rotation boy right here. As built joint. That and that. Rotation around there. Let's turn sketch off. There we go. Looks good to me. Let's make it a little silver. Sure, stainless steel works. And I think I'm gonna actually change this to black plastic. Black plastic, very good. Plastic. Black, 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 black matte. There we go. Cool. All right, and that is that done. So now we just need to make the pulley. And I guess the only thing we really need to do is determine how big we want it to be. Because how big it is, the diameter of it, or at least the diameter of the belt that goes around it, the mean diameter, is more or less what determines how big we have to make the one that goes on the 8mm shaft. So. Actually, turn that back off, turn that off. Let us do this, do that, do that. Click some buttons. 3 points gets us everything, and then We can determine the thickness that we want around here, which I think I'm going to keep at 3, and we'll see how well that turns out. And then... actually, how's the best way... How do I want to do this? What's the best way I want to do this? Because we could design it sideways. Nah, I think I'll cut it sideways. So we could actually design this in one step. So just as an example over here, we could design it on side right here. Do this. Do. Putting our numbers in here, and then revolve this right here, right? And then, actually, I guess we would want to do this. So revolve this around that line, and that would give us both our hole and the whole entire shape of it at once. That's really convenient. Actually, you know what? Let's try that. That should work, and that's probably the more efficient way of doing things. So, guess it makes sense. Guess it makes sense to try it. This is the front side. So I want to design it like this. We just got to figure out what plane we want. I guess I'll just go left-hand plane. What plane we want to do it off of. So, left of flex hex drive. Turn that guy off since we don't need it. And actually, let us create a new component. I think I will put it up here just because I'm going to, it makes it easier for me to just turn this off when we go to print, right? As opposed to coming in and selecting each of the bodies individually. So we'll put it on the top level. Small pulley. And we will use that plane we just picked up. Actually, yeah. So it's going to end up being 2 steps anyway, just because we got to cut a hex. So if we were doing a circle, if we were putting this on a shaft, so when we do the shaft one, then we actually can make the ID of the pulley at the same time. But because we got to cut a hex here, the revolve tool isn't going to help us with that. So it will take 2 steps in this situation, but we're going to do it this way anyway, since we're already here. So this we don't need any meat on. That's our outside. That's that. Let's make sure that this is collinear there, and this is collinear here. And then we only really need to go to center, so I'll cut this off, and we're going to center because we're revolving. That's the reason. So let us, actually, let me Control Z both of those just because I want to make sure that Fusion is not accidentally snagging an edge as opposed to a projection line. There we go. Center point's over here. So this is center point on that guy. And then we wanted 3mm ID from here. Or 3mm of meat around the hex, rather, is what I should say. So I'm pretty sure that does it. We'll see what happens. I'll take a look at it, you know, sketch up a look at it really quick afterwards. And then over here, we're using a 3L belt. So that's 3/8 is what that means. So this right here, and actually, that's right. I probably should take this guy off right here because this is, oh, that is why. So delete that guy. That's the only constraint there. So let us right angle this. And let's see. I'm going to drag this down just to make my life easier. Put a point there and then center this point on here. There we go. And then we can come back over here. And this is parentheses 3 divided by 8 times 1 inch. And if I recall correctly from the diagram that I saw, this is a 40 degree right here. Actually, wrong 40. this is 40 degrees here. I think that's right. You know what? Maybe it was 40 degrees here. Yeah. I think that's where the 40 degrees was. Could just look it back up, but that would make me not lazy. So we will avoid doing that. So. The depth here. The depth here is... I can't remember actually. So I guess I am looking it up. Let's see. Let's drag this off. And let's see. 3L or L3? Is it L3 or 3L? 3L pulley. Yeah. 3L pulley. Correct. Diagram. And let me hop over here. There we go. All right. Now I can bring you guys over here. And images. I guess I should do dimensions instead. Let's see. Whoops. Get back here. View image. Did I have view image or? Yeah, that's view image. All right, there we go. Let's see. A, B. Yeah, see, this is the funny thing, right? Most of the diagrams don't actually give you the depth of the channel. That's something I recall from when I was looking at it, which is a little weird to me. Boo. PD, OD, so OD, PD. Do this. And I am looking for... That is not useful. Alright, never mind. Delete. Whoops. Actually, this works. This works. So the belt is 730 seconds. And I'll just make it the same size as the belt. I won't bother looking for the pulley. So, back to Fujione. And we'll make this 730 seconds. Times 1 inch. Okay, and I actually should fix this right here. So, let us delete that one. Bring you... Oh no, let go. Let go. There you go. Okay. We'll get this fixed, I swear. It will happen. So that on there. That on there. That on there. That on there. And then this is what I wanted to do. I wanted to give us meat here, which I will call... Let's see. I mean, it's just outside the belt, right? Like, it could be 8 millimeters or 2 millimeters. I just wanted a little bit of meat. Actually, you know what? Maybe I shouldn't. Maybe I shouldn't. Let's see what happens. We'll see how this prints. Normally, I like to add extra meat around the edges, but doesn't necessarily matter, I don't think. And then we just need however much meat we want over here. Or actually, probably better to do however big we want this at this point. So that's an inch in radius. So if we go 0.5 inch, there's our 3 millimeter line, so we can see that we're below that. So let's see, 12. Let's go 15 then. So that should be fine because that gives us our 3 millimeter meat plus a little bit extra. We could line this up, but I want a round number because we need to go 10 times, right? in order to get our ratio right. So I want a number that's easy to work with. So we'll stick with the 15. So. On to the main event, which is revolving that. And there's our pulley. Yeah, see, I can just... Yeah. Alright, remember what I said about this guy? So... That should be... So the funny thing is that I deleted that one last time and it disconnected. There we go. The other one. That guy. Alright. 2 millimeters. Yeah, it's not so much the edges that I'm worried about, it's more down here. That would have been super thin, so if we just take a random point down here now, obviously this is going to be more than 2 millimeters, so that's about 3 millimeters in the center. And 3 millimeters of meat is probably alright for right now. We can go ahead and increase that later if we would like to. And back to you, Bob. Alright, cool. Cool. And then we have an option here on... I'm just going to turn these lights off since they're in my face. We can either go ahead and just do our combine here. That is not centered. Fascinating. Oh, that's right. I guess that would not be centered. That makes sense. Anyway, so I guess at this point, let's get it centered. Because I went off the side, I could have... It would be centered if instead of using the left side, if I had created a mid-plane on the hex. You know what? Let's go ahead and do that. That is the better way of doing it. So let's admit our mistakes and not, run away from them. So through 2 edges, that's the mid-plane right there. That is the... X mid-plane? Yes, X mid-plane. I don't know why I derped on that. Normally I get that one pretty quick. X mid-plane. Cool. And then we will hop back down here. Redefine sketch plane. Oh, never mind. We will not do that. Hop up to the top. Drag this back. Redefine sketch plane to be the X mid plane. Okay. Check our... Yep. So our projections broke. So let's fix that. And I'll take the intersect now that we're on the inside of the body. And just fix that. And make that collinear with this little guy right here. That guy? Nope. Out of my way. There we go. And now this needs to be, let's turn this body off really quick. 3 millimeters, and we're back to where we're at. But now we are centered. So the option, like I said, is we can just combine this. And let me get back into the component. Combine that with that. Cut. Keep tools. We can blow this all the way out the bottom if we want to. I don't think I will. I think I'll go ahead and leave it blind as a blind hole right here. And just offset for printing minus 0.1 and start labeling stuff. Design body X drive and X drive offsets. And you know what? I'm also going to just drop the floor down a little bit too, just to give ourselves a little bit of extra space. And that should be good. Now we can come up here and rigid these guys. Rigid group, no children, that one and that one, okay. And now both of these spin at the same time. Which you can kind of see, but you kind of can't see because there's no textures. So, that is the small pulley. Shouldn't have any problem printing that. And now we can move on to the big pulley. This actually, we were just sketching out, right? I think I'm going to delete this altogether. Actually, there's no need to delete it. We'll just... Let's see, where is that at? Because that probably should not be on that. I'm assuming that's the bottom of the center shaft. Yeah, it looks like it is. So I'm going to delete both of these. And we'll come back to the center shaft. Toss that in here instead because that is more logical as a reference. Alright, now we can come back over to the pulley. Grab that plane. Actually, I said that, and then I realized we don't want to do that. So let's see. We need a center plane. We have an extra plane we don't need, but that's okay. Mid-plane, mid-plane, mid-plane. We do not have a mid-plane on the disc. We don't have a mid-plane on the center shaft. We have a mid-plane over here. Alright, we do not. So I guess I was just working off of the origin, which is not ideal, but we'll cope. Turn the small pulley off. Grab the center shaft. Project it. Okay. Down to the bottom. Actually, you know what? I was between projecting it and intersecting it again. I can't think of a good reason why we need to intersect it, so we'll just do this. Put our numbers in again. There. 2 millimeters. This is parallel to that. This is 40. This is not a right angle. Center to center and right angle this guy to keep it centered. And then we had 7/8 of an inch times 1 inch. Oh, no, it wasn't 7/8. It was 7/30 seconds. I was incorrect. 7/30 seconds. Control Z. There we go. This is 3/8 right here. Times 1 inch rather. There we go. That's centered there, so now we just need from here to here. I want 3 millimeters. And like I said before, if we put this line in there, then we can actually revolve the ID as well. And everything is constrained, so I think that's everything we needed. So. we will go ahead and move forward. Let's rename this to large pulley. Revolve that guy around that line. And there's ID. That works great. Rename. Body. And that is a heck of a lot simpler than putting teeth on a 2G2, or 2GT rather, pulley. So we are happy. Just put an offset in here for printing. And I just realized this is not acceptable. This distance right here we need to be 15 times 10. Okay. 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 That's what it is. That's what happened. I see what happened. I see what happened. 15 divided by 2 times 10. There we go. That's better. Because it's radius. It's radius, so we need half of that. Unless, let me come back over here to small pulley. I screwed up small pulley as well, in which case... Yep, okay. So that is 15 millimeter radius. So since that's a 15 millimeter radius, that would mean that we do need 15 times 10. So. Back to that 150 is quite large, frankly. You know what? I'm tempted to try it anyway. It's a lot of torque on the shaft. We do need to key it to the shaft. Memo to self. I guess we just pin it to the shaft. We'll give it a collar and pin it to the shaft. I'd like to do a collar on both top and bottom, but that's a bit awkward to print. So this actually does need to be this. So instead of doing both top and bottom, we could do 2 pins on the top, which is a little silly and I don't know that I've ever seen before, but we could try. So this is my 3mm pin, and then about 3mm here. This is all construction lines for future reference. There's that. And that can also be tangent to that because that gives me my 3mm of thickness. We'll go ahead and do this as well. And then toss another one exactly the same way on top. Again, can't say I've ever seen this done before, but we'll try it. And this one, actually, I'm going to do this. I'm going to put that in there. Let me delete that. Just toss this all the way up. Okay, so we grab that and that. And then we can grab that pinhole, symmetric all. Okay, that's one pinhole, and then there's no like circle and step Z, is there? I don't think there is. No step Z. Yep, no Z offsets. Okay. That'd be an easy way to replicate that, but at this point, I guess we'll just have two, and since we're working off origin, we know already, we can just come here, project out that point right there. Rather than do that, let's do that. 3 millimeters, and get that cut. So, that is not necessarily ideal. Actually, you know what? Let's even take, let's see, this guy. Yeah, that guy. Let's toss another one in here. And make this 5 millimeter. Actually, that would not be that. Control Z, Control Z. Just do this instead. Makes more sense. Make this a little beefier. 5 or 6. I guess 6. Just make the collar a little bit beefier. And we'll see how that works. Not thrilled with it, but if it works, it works, you know? So, let us zoom on out, and now we need the cage now that we know where everything is. Yeah, that's not gonna work actually. Okay, at that point then, at this point then, we will have to do 2 steps here. So this will only be half of our finish. Let's see how that looks. It's close to the same size as that one, so I guess that's okay. The only problem is that getting the other 5-to-1 in here is going to be a little bit of a problem. Fitting it in, I mean. Let's see what 3-to-1 looks like. Oh, this number this time. Yeah. So I technically laid that math out wrong. Technically speaking, it still worked. It really should have been this is what I should have typed in there for representing 10 divided by 2. Right? Yes. If I do that, so that's actually that doesn't look right, does it? Five. So that would be 2 5-to-1s. Yeah, so it should be, yeah, 10 divided by 3 is 3.333. That makes sense, right? And then each one of these is a 1-to-3. Man, if only the Dremel ran a little bit slower. It's one of those things, it'd almost be easier. I mean, not almost, it would be easier just to use my drill instead to run this, but that was not the concept behind this. So we were going to stick to the concept. One of those things, by all means, if you want to replicate this yourself and don't want to use a Dremel, I would recommend using the drill instead and just swapping out, you know, the appropriately sized nut. Just mount an appropriately sized nut in there. Hex drive, I should say. Hex drive in there. Yeah. Alright. 10 divided by 3. I'm a little surprised that's only 50. Let's see. 15 to 50 is 45 and a little bit. Yeah, I guess that makes sense. No, that makes sense. Okay. My only problem now is, though, that doesn't give me as much space as I wanted, I don't think. So if I draw a square, what I need to do, what I'm trying to achieve here, is I'm going to make the cage, right? I want the cage to be pretty close to the same size as the sanding disc. That's the point. But if I got to put another 50mm disc in here, or rather 100, it's a 100mm disc because that is radius. So you see how it doesn't really fit between this corner and the shaft right there, which is what I need it to do. So. We could stack it up, I guess. We could make it taller. That would work. Question mark, I think. A little awkward, but I think it will work. So let's minimize this length right here, because I just kind of threw that length in there as an arbitrary number. So make that 3 inches, just to shorten it up a bit. And then what we're gonna have to do is come back to the large pulley. Come back to here. Instead of this, and I guess this. Oh, there it is. I am blind. Huh. I would have expected, because I deleted a right angle, so I would have expected something to... Let me Control-Z there really quick. Yeah, that right angle right there. But everything else looks like it's still constrained, despite deleting the right angle. Let's see. So really I want to... I don't have a collinear on this. There we go. That's what I wanted. Alright, cool. What is this right angling? Okay, that is right angling to that. That's fine. So we're going to move this up a bit, is the point. Oop. Double line. There's that. We'll give ourselves... I'm gonna give myself a little bit of lee room here. So I guess... Actually, should probably give myself enough lee room for the bottom bearing. I wasn't sure where I was putting the bottom bearing, whether or not I was putting it above or below, just because it doesn't necessarily need to be in any particular place. But I guess if I put it below... Wait, why is this driven? Huh. Weird. Alright, so let's drop a bearing down here. So, bearing... B608 thickness. That should be good. Maybe +1 for the extra space. And what is this? Okay. Toss that in here. That collinear to that. That on that. There we go. Okay, that's fine there. So there's that. We will, I guess, toss another pair of bearings. Makes sense. So. Let's come over here. Come up here. Grab another bearing. Actually, you know what? I was just copying it earlier, so I guess we'll just copy it like before. Copy. Boom. Should probably just make a new component. Center shaft. Connector. Let's get the bottom of that pulley. This was just me scribbling, right? I believe it was. Yes. Large pulley, cross pin. And we already called that bottom pulley, so now. No. Center shaft connector. There's that. Project out the shaft. Okay. Look at it. Turn some stuff off. Toss a wall on it. Extrude it. Minus thickness. Okay, and actually offset it by that 1 millimeter that I give myself. -1 millimeter. Am I going the wrong direction here? I am. I am upside down right now. There we go. And then we just go ahead and put a separator in there. Just call it like a millimeter, I guess. Actually, take that back. Come back in here. Back to pushing these things out. Blah, blah, blah. Yeah, we'll do it in 2 sketches. That's fine. It's fine. Let's paste in here. Paste new. Okay. Align. That is a center shaft. That was silly of me. OD. There we go. And then this is 3. Finish. Change this to only be that. There we go. Catcher position. I don't really want to make another plane right there, so let us grab that as a reference, grab that as a reference, turn some stuff off, do just a little bit on the inside there, and extrude that from object, and then like I said, just like 2. Yeah, it's gonna be a little difficult actually, it's occurring to me to pop that out when I got both of them in here, but we will survive. The point being is that my plan was to do this from object, thickness, do this. This was my plan. So we got a bearing on the top, bearing on the bottom. Base new. Okay, align. And like I said, this little pushing recess that I have in here, in order to press them out. So you can see how I can put a peg in there and press that out, right? That's not going to work terribly well when I've got this one in the bottom in my way. So, again, we'll have to live with that for the time being. But. The trick here is now how to keep this in place, because my plan was to have that shaft running on here and then putting a second shaft down here with another pulley. Because we're going to have 3 pulleys. We're going to have 3 pulleys available, so 1 on the Dremel, 2 a large one on the bottom here, large one, small one attached to the large one on the bottom here, running over to a large one attached to a small one, which goes back to the large one on the center shaft here. So that was the way I was going to lay this out. But this is kind of floating in space right now. It does not need to be terribly rigid or anything like that. It needs to be a little bit rigid. It needs to be a little bit rigid, but only just so much. I'm not sure if maybe I use some extra 2020 extrusion and then we put a flange on this. That may be the best way to go about it. Is I'll put a flange on this and then mount it to 2020 extrusion in the middle. Yeah, it makes sense. So. Let us make another component. I forgot to label this stuff, so we'll go ahead and get this stuff labeled. Design. Center, or middle, I guess. Top. Rename middle. And rename bottom. There we go. And for this shaft, I guess we just start it from the bottom of the middle. There we go. New component. Let's see, so this needs to be thickness times 2, times 2, and then we need the pulleys. We need 2 pulleys. Let's go 50, and hopefully that works. Plus 50. Hopefully that's enough. If it isn't, we'll come back and fix it. There's actually a little bit of leeway in here, so not that big of a deal. Alright, so. Just thinking about whether or not I want to make any changes here or not. I don't think I do, so. Oh, I don't think I labeled the bodies up there. Body, nope. Alright, so that's that. So, now what I think I'm going to do is new component, compound pulley, and then boundary fill these two. I think that's what I'm going to do, and then I'm going to put them together, and then we'll see how it turns out. So we'll turn the other guys off so we don't accidentally touch them. There we go. And there's the center shaft there. Get all this stuff put away. Alright, so align that to bodies, that, and then we'll extrude out, and we should be good, I think. I think that's all we really need to do. So do this. Don't keep tools, join. Okay. Put a plane here. Dun, 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 dun. Prong pulley. Grab that plane. Project out that. Project out the shaft. Okay. Actually, we didn't need to project out the pulley itself to begin with, but that's okay. There's that. There's that. Yeah, let's just delete it. Turn off the shaft. There I am. I am blind. This body back on. Metric, all, does not create a tool body on top. Did not actually complain about this time. Funny, did not complain about it this time. This is admittedly a little weird. Have the hexes in here. So let's go ahead and fix that. Project out. You know what? I'm just going to call this 10 millimeters. Finish. Step back a step. Profile. Profile. Distance to object. There we go. Join. Okay, and then step through. And much better. Rename. Center hole. Okay. Turn that off. Now, now. Turn the shaft on. Align that to the bottom of the center shaft connector. And then we just slide it down a hair. 1 millimeter is fine. And we just need, actually, let me find out what this is to begin with. That's 45 and 0.05, so 45.05. So we had 50, we had counted for 50. So we should be good just sliding another, whatchamacallit on here, another paste new bearing on here. Align. Okay. Actually, you know what? Rather than do that, let's just align it with the bottom and leave our extra space in there. It's not an unreasonable amount of extra space to begin with, so here we go. And I guess we just do a bottom reduction base here. Do we have a bottom of shaft? We do not. There we go. There we go. Project out the shaft and let's turn some of this stuff off. There we go. And just grab. Why is that hollow? Why is my bearing hollow? Oh my gosh. Our bearing lost its innards. Huh. Do I need to fix that now? Excellent question. Let us come back up top. Where is that alignment? That's that. This should have been components. Is what it should have been. Okay, capture position. Up down here. Up down here. There we go. And back to work. Work, work, work. Finish this up. Again, a spot to push out the bearing is the only thing we really need now at this point. Alright, cool beans. And now extrude. To object. Whoops, to object. Turn the bearing back on. Missed the bearing. Okay. What did I grab? That was silly. That is not the correct projection there. Finish. Actually, wow, I made this mistake earlier too. Obviously, I'm not with it. I need an outside wall, guys. Outside wall. There we go. Okay, and then the bottom. Cool. And then the offset. I don't really need that one. Alrighty. Do-do-do. And let's take a quick look. After I get some water. Alright. So there is that. That is fine. Reduction here. So now we just need to position another reducer. Let's see. Squeeze it in as best we can. It's going to be a little rough, but we will survive. I guess I am going to... How are we going to go about this? I'm gonna lie, this has me a little concerned. There's a lot more moving parts now, so there's a serious possibility that something goes horribly wrong here. Alright, we'll design it, but things may need to be rethought at this point. Let me take a quick look at the small pulley again. With this radius, there's our 3mm, so we're really only over, we can only really save unless we want to cut down on the wall thickness between the hex and the V groove. If that's the only place we can really save space, and we can only really save like a millimeter at this point. Only save a millimeter. Alright, well, nothing really but to do it. So, new component, intermediary pulley. Okay. And I guess we'll come back over here really quick. And then there's the compound pulley. Tossing construction on the bottom there to draw off of. Now the funny thing is that I'm sitting here, and when it's this compact like this, part of me thinks we should just move to gearing. I was going to avoid doing gearing just because plastic gears tend to be pretty loud. And I mean, that's really about it though. So slipping on the belts actually gives like it has a good benefit to it. We don't need to keep sync with anything, unlike, for example, a metal lathe. A metal lathe, you want to keep things in sync, but with this this sander, having the belt be able to slip actually supplies a good bit of disaster avoidance. You know, things get rough, let's say. So if things start going south, then it doesn't actually damage anything by it just slipping. So it's better for it to be a pulley. It's just the amount of space we're losing right here is a little obnoxious. I guess, you know what? If this doesn't work, we could go back to the super large disc. And the reason we could go back to the super large disc is because I did have this idea to put a little rack on the side here for mounting jigs and stuff. So if we were going to use this space anyway for mounting jigs, let me just hop in here, check this out. That is the disc, right? Yes, it is the disc. So if that was the case, our guy over here, let me toggle this to radius. Attempt to toggle to radius. There we go. And we said this was 15 times 10. Actually, that doesn't fit on the printer. Never mind. 15 times 10 does not fit on the printer. So yeah, alright, never mind. That idea was, I was just thinking if I had a box over here and just put this over here, then that wouldn't be that big of a deal. But, not gonna work one way or another, so. Just get at it. Get it done. This is bottom of small compound pulley. There we go. And I want to project out a couple things here. I want to project out that guy so I know where I'm going. This guy so I know where or what the size is. And then we are going to put the shaft in a spot, and then after that, or actually leave all that on, do that one instead. And then once we have the shaft in place, then we will copy and paste, or not, boundary fill rather, is what I meant to say, boundary fill stuff. So, I'm gonna have this guy with some amount of offset here. I'm not really sure what is an appropriate amount of offset. Back to, we were talking about this last time. This angle right here is supposed to be like over 60. Or I guess maybe it was... Let's do this really quick. Get this lined up. Let me just play with this really quick. What is going on with you guys? Why do you guys not want to tangent? I don't see any right angles here, so I'm actually not sure why it doesn't want to... Oh, I know why. Because of that guy. There we go. That's better. Okay, okay. So it does get wider that way. One thing is, oh. Yeah. Trying to figure out where the 60 degrees is because like okay, so that's, let's call this 60. Yeah, so I can move this out one way or another. It's my only weird thing that I'm not getting about this. So I don't think I'm measuring the 60 degrees right, is what I'm getting at. Which is a little bit of a problem. Because my real question here is how close I can get to here. So this is supposed to be equal to that, to the bigger one. And then this is going to be tangent to here. This distance right here can be whatever I want. This is just an offset. Some extra space between the pulleys. One of those things, if these were gears, then this would actually be tangent right here. This would be, this inner circle would be tangent to that circle. Assuming these are pitch circles, pitch diameters. I just don't know what is appropriate for the angle here. So, I guess that's what we'll do. And I will just take an arbitrary horizontal line there just to line it up. This is all that, and then this is my 8mm shaft. And let's turn this on, and I will go from object, because we're going to just use the same exact base over here that we have over here. We'll go from there, and then we need to go all the way up to the top. Large pulley. Yeah, I guess I'll just take this as a reference. Whoops. No. You are this. And to object. There we go. That, and then add the thickness. +1 for some buffer room. Stinks that I gotta do this, but that should have been a new component. Point being. That to okay, there we go. Let's rename this because this isn't actually the pulley. Bum 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 dun 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 dun. Now, in theory, should be able to do 2 boundary fills here. That was not a boundary fill. That guy. New component, okay. And line that on here, and then we'll just slide it up a little bit. And that should line up because they're the same belt size, and that's a little sketchy. Alright, let's get the other guy in here first, and then I will come back and worry about that in a minute. The simple solution, honestly, is just to do this, minus point, 5, let's say. And trust ourselves to be fine. Which is asking a little bit, but, do do do. Do do do. There we go. Let's toss in some bearings. Actually, the bottom, and this should be components. Stop selecting bodies. Dun, dun, dun. Boom. Now we create the bearing holders. Generator bottom bearing housing. Let's get the bottom of the shaft as a reference. Capture position, please. Thank y'all. Cool. Come back down here and draw the same exact thing that we had been drawing before. And make sure we grab the outside of it and don't be silly this time. And the shaft. Bone centric. 3 and 3. And 3 this way. And the rest of this. Or actually not that one. Not that one. Not that one. That bearing to the top of that guy. To object there. Okay. Okay. Easy peasy. Up to the top one. New component. Top bearing housing. Grab the top of the shaft now. There's that. One of the things, I could just copy and paste these guys, but just in case something changes in the future and I want to change how these are connected, that is why I am going through the trouble of recreating it each and every single time. Three and 3. Well, not actually 3, but you know what I mean. Distance to object. Did I lose the body again on this guy? No? Why don't I see the body here? What did I project? What is this projection? Okay. Whoops, not what I intended. Alright, cool. And just toss this guy in here. Alright, and then one more thing we need to do is add the pins to the, or well, fix this guy up. At that point, it's one of these things, it shouldn't really, we only really are going to need to move the top bearing up. The rest of the projections and whatnot should all be safe, but once we get the pin in here, then that's going to shift everything up because I forgot to account for it. So whoops. No, that's right, that's right. Let's do this. I'm gonna do this in a couple steps. Just going to make sure that that is full first, and then we'll come back and create this guy. And this guy will be, I guess 9. I guess 9 is fine. And then we'll toss the bottom one there. Distance all. Flipperooski. Cut. Okay. Pin design. Color, ID, and let's see. We're not on center anymore, so we're going to have to grab some kind of tangent, I guess, off the shaft. Tangent. That. And where's your origin at? Origin. Alright. It doesn't necessarily matter to me which tangent it is, so we'll just use that. tangent of turn that origin off. Project that guy. We'll see how well this holds up. Just using one pin on that guy. And Control Z, rename, cross pin, and that is, let's see, actually I think I forgot to turn the body back on over here. I did. Yep. Let's turn the rest of this guy's on so we can see what we're looking at. Oops, not P. P in the slicer, for the record, is how you toggle visibility or printability. So that is why I hit P. No sketches are on, right? Nope, doesn't look like it. Alright. That center shaft on, disc on. M8 nut can be on for the heck of it. And let's get some colors in here. Do I already have a blue somewhere? For some reason I thought I did. Oh, this, where's the hex drive at? Oh, it's center pull, or a small pulley? Okay. Turn that guy off right now. Alright, and we got a lot of colors to apply, so it will be whatever I grab first. Just go down the line. Don't have a green yet, right? A matte green. White. Actually, let's not put white there. Just because it's close to the beige. So we'll put it up here instead. That looks to be a sketch up there, which I thought that I looked for and obviously did not. And adjust this down here. Needs plastic. Yeller. There we go. Alright, so yellow's kind of close to beige. We'll do blue instead. Alright, so again, more convoluted than I had wanted to, but we'll see whether or not that works out. So. Yeah, I think I'm probably gonna hour 45 minutes. Could go, I mean, I don't think if I just go to 2 hours that we'll have the frame done, because basically when we do the frame here, I'm going to have to connect all this stuff up, all these guys up to the frame in order to support them. So that seems like that's going to take a little bit of work. And therefore, I don't think we're going to be able to get it done in 15 minutes, so may as well just call this a stream right here. And by the next stream, I will obviously have the V-groove, the adjustable V-groove in, so I can see how well that works, and I'll probably set up a test rig for at least one of these. Like, for example, I might print out one large and one small pulley, set up a test rig just to make sure it's working out the way I need it to with this spacing that we have right here. And so long as that works out, then we'll know that we're safe to continue with the shell, with the cage, with the frame, whatever the heck I want to call it. And that should be it. So, as always, guys, thank you guys for watching. For other streams, one of those things, as I've stated before, probably fewer streams in the intermediary because I'm trying to get videos out to complement the streams. I decided that I will do a video for a project that I'm doing at work. So that is actually going to take precedence because as soon as I have that project set up, then I can start recording at work where I have more space. And again, I needed the more space, as you may recall, because I have one very large project that will not fit on my desk to show you guys. So, plus, when I record videos, I prefer to have more space anyway, do actual videos as opposed to these streams. So that's all tied up together. So one of those things, that video I am very close to. I just need 1 or 2 more things to finish off that project at work. Just need to pick those things up. I've got the rest of the design certified as functional, so I don't need to change anything with it. I just need a couple supplies. And then I will go ahead and show you guys that. And from there, I will get the other videos recorded, and that will be that. Otherwise, for streams, I may hop on and play some video games. I keep on saying that, and it keeps on not happening, but I swear one of these days, I will get some video game streams in. Just got a bunch of work otherwise is the only real reason not to stream the video games. But beyond that, that is, well, alright. Light Lake. Obviously, I am behind on Light Lake. I knew I was behind on Light Lake. I acknowledged it. And I said it's not that big of a deal. We'll get it done. I actually have not put any more work into Light Lake since then because there has just been so many other projects on my mind, and I should get back to Light Lake. It's just a matter of finding the time. So, Light Lake I do want to get done. I promise it's coming. It would be really stupid to put all these hours into it and not have it complete. So, one of those things, as a matter of principle, pride, and practicality, Light Lake is going to get done. You don't have to worry about that. That's not going to be a project that just disappears off into the aether. So, with all that said, thank you guys for watching, and I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.